In the last episode, we learned to install Linux step by step. In this episode of our series, Linux Essentials, we will understand Linux file system. Hello everyone, my name is Sohail and welcome back to Linux and Beyond. Let's start with the basics. What is a file system? How does it organize and manage data on your Linux system?
In Linux, the file system is a hierarchical tree-like structure with directories and files. So if you open your file manager and go to file system, you'll see that there are a lot of files, and all these directories contain files that are essential for running the operating system. So we'll now see what each of these directories mean. So we'll start from root directory.
Think of the root directory as a counterpart of the C drive in Windows. It's like the heart of the operating system, storing all the essential files needed for everything to run smoothly.
The directories you see here are a part of Linux file system hierarchy, which is commonly followed by Linux distributions. However, some systems might have additional directories created for specific purposes, or some directories may be omitted if they are not needed. For example, a minimal or specialized Linux system might have a fewer directories, while a more customized system might have additional directories beyond a standard set. So let's start understanding what each of these directory does. The first directory inside root, called bin. Bin contains essential command binaries needed for system repair and recovery. The next is the boot. Boot contains files that are required for the boot process, such as the Linux kernel. The dev directory in Linux is a directory that contains device files. These device files represent physical and virtual devices connected to the system, such as hard drives, USB devices, serial ports, printers, and so on. SC or ETC contains system-wide configuration files and shell scripts used to initialize system settings. In other words, one of the most commonly used directories by system administrators. This is where applications store configuration files, and modifying any file changes the behavior of the corresponding application. Next is the home directory. Home directories contain user-specific subdirectories. Each of these directories corresponding to a user on the system. So by default, no user is allowed to access or modify files stored in other users' directory unless they are provided proper permissions to do so. For example, the root user and administrators with appropriate permissions can access files stored in other users' home directory. So let's say there are 3 users on the system, then there will be 3 directories inside the home directory. The next one is the lib directory. It contains shared libraries needed for programs in bin or sbin. Next is the media. The media directory is used as a mount point for removable media such as USB drives. So whenever you insert any USB drive, this is the directory where it mounts your USB drive. So when you are using a graphical interface, your file manager shows you the USB drive listed here. But if you're not using the graphical interface, then all you can do is you can open up the terminal and go to media, and this is where you'll see all the file systems that you have mounted. Next one is MNT. MNT is similar to media. It is used as a temporary mount point for external file system. Next is the opt directory. Now it contains subdirectories for optional software packages. Proc, as the name suggests, is a virtual file system that contains information about processes and system resources. Next is the root directory. As I mentioned earlier, that a Linux system has a root user. So just like any other user has the home directory, in the same manner, we have a root directory, which is a home directory for the root user. The next is the run directory. The run directory is a temporary file system used by Linux distributions for storing transient runtime data. It is often mounted as a tempfs or temporary file system during system boot to provide a temporary storage space for various system components and applications. Next is the sbin directory. Now sbin contains essential system binaries for system administration. The next is the SRV or service directory. The service directory contains data for services provided by the system. The next is the sys directory. The sys directory contains files that provide information about devices, drivers, and kernel features. Next one is the temp directory. As the name suggests, it is a directory that is used for temporary storage of files. So each time when you restart your system, all data stored in the temp directory is removed. Next is a USR directory or user directory. Now this directory contains user binaries, libraries, documentation, and source code. And finally, we have var or variable files. Now this directory contains variable data such as logs, spool files, and temporary files. In the next episode, we'll see how we can fetch different logs from this directory.
Keep in mind that this is a simplified overview and the actual file system structure can vary based on the distribution and system configuration. The structure presented here is a standard structure found in many Linux distributions. Now let's dive into some of the most common file systems used in Linux.
From the traditional ext4 to XFS and B3FS, we'll explore their features, use cases, and advantages. Each file system has its strengths, and understanding them allows you to make informed decisions based on your needs. Remember, in the last episode, during the Linux Mint installation, we created multiple partitions and selected ext4 partition type for each partition. ext4, B3FS, and XFS are different types of file systems used in Linux. Each has its own features, advantages, and use cases. Let's briefly explore each one of them.
Starting from ext4 that we created in the last episode, it is a journaling file system and is commonly used in a variety of Linux distributions for general purpose storage.
ext4 has improved performance and reliability compared to its predecessor, ext3. It supports larger file sizes and larger overall file system. To be exact, ext4 file system can store file of size as much as 16 terabytes and can have volume up to 1 exabyte. Because ext4 is a journaling file system, it helps in faster file system recovery after a system crash or power failure. It's also backward compatible with its predecessor ext2 and ext3.
The next is the X file system, aka XFS. XFS is another popular file system for Linux systems.
XFS supports larger file sizes with maximum file size limitations of up to 8 exabytes more than ext4, making it suitable for handling very large files such as multimedia files and large database files. In terms of volume size, XFS supports large overall file systems. This massive scalability makes XFS suitable for large-scale storage environments such as enterprise-level storage systems or data centers.
And finally, BTRFS, or short for B3 file system, an advanced Linux file system. B3FS is a modern and powerful file system designed for Linux.
Similar to ext4, B3FS is also a journaling file system commonly used in various Linux distributions for general purpose storage. However, B3FS offers several advanced features that set it apart. The file system boasts improved performance and reliability over traditional file systems like ext3 and ext4. It supports larger file sizes and file systems, making it suitable for handling massive amount of data. To be more accurate, it allows us to create or store file of size as much as 16 exabytes, which is even more than XFS. Another standout feature of B3FS is that we all can utilize its support for advanced storage capabilities like snapshots, checksums, and RAID-like functionality. Snapshots allow users to create a point-in-time copies of file systems, providing a convenient way to revert changes or create backups. Now, a lot of you might be asking, why should I use ext4 over XFS and B3FS that provides slight performance improvement and can handle larger file sizes?
Choosing among these file systems often depends on the specific use case and requirements of the system. For example, ext4 is a reliable and widely used system for general purpose scenarios. B3FS is often selected for its advanced features, including snapshots and file system and flexible storage management. XFS is a good choice for scenarios requiring high performance and scalability with large amount of data. The selection can also be influenced by factors like the level of community support, compatibility, and the specific features offered by each file system. We often need to access data from other file systems. Next, we will learn how we can mount and unmount external file system or devices to ensure seamless access to data in Linux.
If you are using a graphical distribution like Linux Mint, then you can open up your file manager and check all the devices that are connected to your computer in your file manager. But if you're on command line, then you can use the lsblk command to list all the devices connected to your computer. So lsblk, and now you can see there it has listed all the devices that are connected to our computer. SDA is the first device that contains our operating system, and SDA 1, 2, and 3 are the partitions. Now SDD is a storage that we can mount anywhere on our file system. So to mount this, we can use the mount command. Now, mount requires two options. One is the device and second is the directory we want to mount this device to. So in this case, the device is SDD1, and then we can literally mount it anywhere on our file system, but we have a dedicated directory named media under our root directory that is used to mounting external devices. So we can mount it on media, and inside the media directory, I have created a directory named test, and now I want to mount this device on this test directory. So hit enter, and now it says you have to be logged in as root. Well, I'm not logged in as root. I'll talk about sudo in the next episode. Now we can use same command and SDD1. There you go. So now the storage should be mounted in our test directory. To check, we can move to the mount point, which is media/test, and check if there exists anything here. And there you go. So that is how we can mount storage devices to our computer. And we can also unmount it using the umount command. To use the command, all you have to do is type umount and then give it the device. It says target is busy because I am in the directory right now. So now I can go back to my root and then rerun the command. There you go. So if you now go to media/test, there should not be anything in here. So this is how you mount and unmount any external devices to your computer from the command line.
Like any other aspect of Linux file systems require maintenance. Next, we will learn the routine task of checking file system integrity.
There are various tools to manage and maintain file systems in Linux, but for this video, we will learn a very useful command, FSCK. FSCK stands for File System Consistency Check, which checks and repairs inconsistencies in file systems, which ensures their integrity and reliability. To use FSCK, all we have to do is use the command and give it the device name that we want to check. So in this case, let's go with SDD1, and well, it needs me to be root, and there you go. Because the size of this storage is extremely small, so it just completed almost instantly. So as you can see, the device is clean. So this is how you can check and fix any inconsistencies in a file system. However, it works in several cases. In certain cases, it may not work. So when the device is corrupted badly, then it may not work.
Now remember to exercise caution when performing these operations on a live or critical systems, and always have backups in place before making changes to file systems. As we wrap up today's episode, I hope you have gained a solid understanding of the key concepts. Remember, the choice of a file system impacts how you store and access data. Practice and experiment in your own Linux environment to solidify your knowledge. Here at Linux and Beyond, I will cover more file systems such as LVM and RAID in my upcoming videos. So don't forget to subscribe the channel and hit the like button to get more videos like this. This is all for this video. In the next episode, we will move toward performing more specific operations on Linux machine by learning the essential commands that every Linux user should know. Until then, take care and see you in the next one.